Hi there. This interview simulates a real-world DevOps conversation focused on Terraform and infrastructure as code when things go wrong. These are the kinds of questions that show up when teams have experienced outages, accidental deletions, state corruption, or dangerous changes pushed too fast. As you listen, pause after each question and answer it out loud before you hear the sample response. Explain your thinking the way you would in a real interview, including trade-offs and uncertainty. If this format helps you prepare for real DevOps, cloud, or SRE interviews, subscribe so you do not miss the next session. Let's begin. First question. Tell me about a time infrastructure as code caused an unexpected production issue. A strong answer might sound like this. In one case, a Terraform change unintentionally replaced a resource instead of updating it. The plan looked harmless at first glance, but a dependency change triggered a destroy and recreate. Once we saw the impact, we halted further applies and restored from backups. Afterward, we added stricter plan reviews and safeguards for destructive changes. The key lesson was never trusting a plan without fully understanding resource lifecycle implications. Second question, how do you usually review Terraform changes before they are applied? A good answer could be, I treat Terraform plans like code changes that affect production behavior. I review the diff carefully, especially anything involving destroy actions or changes to shared resources. I also look at indirect effects, like how a change might impact dependencies. When possible, I run plans in a staging environment first. I try to slow down reviews for high-risk changes rather than rushing them through. Third question. Describe a time you had to debug an infrastructure issue without clear documentation. A strong response might be, I focus on building a mental model of what exists versus what Terraform thinks exists. I inspect the state file, review recent applies, and compare actual cloud resources to the desired configuration. I also look at commit history to understand intent. Even without documentation, Terraform state and version control usually tell a story if you take time to read them carefully. Fourth question. How do you balance speed and safety when using infrastructure as code? A solid answer would be, I think about reversibility and blast radius. For small, isolated changes, I am comfortable moving quickly. For changes that affect shared networking, identity, or data stores, I add extra review steps and sometimes manual approvals. Automation helps with speed, but discipline helps with safety. Both are necessary. Now, let's move into technical and scenario-based questions focused on Terraform and infrastructure as code. First question, what is Terraform state and why is it so critical? A strong answer could sound like this. Terraform state is how Terraform tracks the real-world resources it manages. It maps configuration to actual infrastructure. If the state is wrong, Terraform makes incorrect decisions. That can lead to unexpected deletes or recreations. That is why state needs to be protected, versioned, and locked. Losing or corrupting state is one of the fastest ways to cause infrastructure outages. Next question. You run Terraform apply, and it wants to destroy a production resource you did not intend to change. What do you do? A thoughtful answer might be, I stop immediately and do not apply. Then I investigate why Terraform believes the resource should be destroyed. I compare configuration changes, inspect the state, and check provider behavior. Sometimes it is caused by an attribute change that forces replacement. Other times, it is state drift. I do not proceed until I fully understand the reason and have a safer plan. Third question. How do you handle drift between Terraform state and real infrastructure? A good response could be, I start by identifying what changed and why. Drift can happen because of manual changes, automation outside Terraform, or provider issues. Depending on the situation, I either import the changes into state or revert the infrastructure to match code. The important part is deciding which source of truth should win and making that decision explicit. Fourth question. What are some risks of using a single Terraform workspace for many environments? A strong answer might be, using a single workspace increases blast radius. A mistake can impact multiple environments at once. It also makes access control harder and complicates state management. I prefer separating environments with different state files and often different backends. Isolation reduces risk and makes recovery simpler. Fifth question: how do you protect Terraform from being run incorrectly by the wrong person or at the wrong time? A realistic answer could be: I rely on a combination of access control, remote state locking, and CI pipelines. Direct applies from local machines are limited or restricted. Changes flow through version control and automation, so they are reviewed and auditable. Guardrails do not replace good judgment, but they prevent simple mistakes from becoming disasters. That concludes the first part of the interview. Let's continue with deeper technical and scenario-driven questions focused on Terraform and infrastructure as code failures. Next question. You discover that someone manually changed a production resource in the Cloud Console, and Terraform now wants to revert it. The manual change fixed an urgent issue. What do you do? A strong answer might sound like this. I first confirm that the manual change actually resolved the issue and understand exactly what was changed. Then I decide whether that change should become the new desired state. If it should, I update the Terraform code to reflect it and refresh or import state as needed. If it was only a temporary fix, I plan a controlled rollback using Terraform. The key is not blindly applying Terraform without aligning code and reality. Terraform should follow intent, not erase it. Next question. Your Terraform apply partially succeeds. Some resources are created, others fail, and now the system is in an inconsistent state. How do you recover? A thoughtful answer could be: I start by stabilizing the system and avoiding further applies until I understand what happened. I review the apply output to see which resources were created and which failed. Then I inspect the state file to confirm what Terraform believes exists. Depending on the situation, I may need to import resources, taint them, or manually clean up before reapplying. Partial applies are risky because assumptions break, so I move carefully and document every step. Next question. How do you handle secrets in Terraform without exposing them or creating security risk? A strong answer might be: I avoid storing secrets directly in Terraform code or state whenever possible. I prefer referencing secrets from external systems like secret managers and passing them at runtime. I also ensure state is encrypted and access is tightly controlled. If a secret ever ends up in state, I assume it is compromised and rotate it. Terraform is great for wiring systems together, but it should not be the long-term storage for sensitive data. Next question. You are upgrading a Terraform provider, and the plan shows many unexpected changes. How do you approach this safely? A solid answer could be: I treat provider upgrades as potentially breaking changes. I read the provider release notes carefully and test the upgrade in a non-production environment first. I compare plans before and after the upgrade to understand behavior changes. If the plan includes destructive or unclear changes, I pause and investigate. Sometimes pinning the provider version is safer until there is time to refactor. Upgrades should be deliberate, not automatic. Next question. What are the trade-offs between managing everything in Terraform versus mixing Terraform with other tools? A realistic answer might be: using Terraform for everything gives consistency and a single source of truth, but it can become rigid for fast-changing or ephemeral workflows. Mixing tools can add flexibility, but increases cognitive load and drift risk. I usually keep core infrastructure in Terraform and allow application-level tooling to handle more dynamic behavior. The trade-off is between control and agility, and the right balance depends on the team and system. Final question for this section. How do you design Terraform modules to reduce the chance of catastrophic mistakes? A strong answer could be: I design modules with clear inputs and minimal side effects. I avoid hidden behavior and make destructive actions explicit. I also add safeguards like validation rules and sensible defaults. Good modules are boring and predictable. They limit what callers can do and make dangerous actions obvious. That reduces the chance of surprises during apply. That concludes the core technical discussion. Now let's move into the pressure section. These scenarios are intentionally uncomfortable because Terraform failures rarely happen in calm conditions. First scenario: It is during business hours. A Terraform apply is running through your CI pipeline and suddenly starts destroying resources in production that were not meant to be touched. Traffic is dropping. The apply is still running. What do you do? A strong answer might sound like this: I stop the apply immediately to prevent further damage, even if that leaves the system in a partially applied state. Preventing additional destruction is the first priority. Then I assess what has already changed and stabilize user-facing impact, possibly by restoring critical resources manually if needed. Only after the system is stable do I investigate why the plan allowed this in the first place. During the incident, speed and containment matter more than purity of process. Next scenario. Your Terraform state backend becomes unavailable or locked during an incident. Engineers are blocked from making changes, but production is unstable. How do you handle this? A thoughtful answer could be, I avoid forcing state unlocks unless I fully understand the risk. I first check whether the instability can be mitigated without Terraform, such as scaling or reverting application changes. If infrastructure changes are absolutely required, I carefully evaluate manual actions with clear documentation so state can be reconciled later. Terraform state is a safety mechanism, and bypassing it should be a last resort. I prioritize stabilizing production while minimizing long-term state damage. Next scenario. Leadership asks you to push an urgent Terraform change directly to production without the usual review because the issue is highly visible. What do you do? A mature answer would be, I slow the conversation down just enough to explain the risk. I propose a minimal, focused change that addresses the immediate issue rather than a broad update. If possible, I still require a second set of eyes, even if the review is fast. Skipping safeguards entirely often leads to compounding incidents. Urgency should reduce scope, not remove discipline. Next scenario. You discover after an incident that Terraform drift had been accumulating for months, and several engineers were making manual changes without updating code. How do you address this going forward? A strong answer might be, I focus on fixing the system, not blaming individuals. I work with the team to understand why manual changes felt necessary. Then I improve workflows, so urgent fixes can be captured in code quickly. I also introduce regular drift detection and clearer ownership of Terraform-managed resources. Drift is usually a symptom of friction, not negligence. Final pressure scenario. A junior engineer runs Terraform apply against the wrong environment and causes an outage. How do you respond? A realistic answer could be, I treat it as a process failure, not an individual failure. I help fix the outage first. Afterward, I review why it was possible to target the wrong environment so easily. That usually leads to better environment isolation, clearer naming, and stronger access controls. Psychological safety matters. People learn faster when mistakes lead to improvements instead of fear. That brings us to the end of this Terraform and infrastructure as code interview. These scenarios reflect the reality that Terraform is powerful, but power comes with risk. What separates strong engineers is not avoiding mistakes entirely, but knowing how to respond when things go wrong. Take a moment to reflect on which question challenged you the most. Was it stopping a dangerous apply, dealing with broken state, or pushing back under pressure? If this interview format helps you think more clearly about real-world DevOps problems, subscribe so you do not miss the next session.